Hi friends, welcome to my channel MATHOPHOBIA. I am Sumati, Associate Professor, Department of Mathematics, RMD Engineering College. In this video, I am going to give a brief outlook about the origin of graph theory, Königsberg Bridge problem. Before entering into this video, let us start with one game. Here, there are 4 land areas which are connected by 7 bridges. Is it possible for a person to take a walk around the 4 land areas starting and ending at the same location and crossing each of the 7 bridges exactly once? Let him try. No, 2 bridges are twice used and 1 is not used. One more time. Again, 2 bridges are twice used and 1 is not used. So, it is not possible. Why is it not possible? Let us go back in the medieval of 18th century. Königsberg was a city in Prussia situated on the Pregel River. Today, the city is named Kaliningrad and is a major industrial and commercial center of Western Russia. It became a tradition for the residents of the city to try to take a walk around the city in a way that only crossed each bridge exactly once, but it proved to be a difficult problem. So they approached a famous mathematician, Leonhard Euler. Leonhard Euler is a Swiss mathematician and physicist, astronomer, geographer, logician, and engineer. He introduced the notation we use to write the mathematical function, that is f of x. And his famous max formula is e power I pi plus 1 is equal to 0. He assumed the 4 land areas as vertices A, B, C, D, and he connected all the vertices by 7 edges. This solution is considered to be the first theorem of graph theory, which subsequently led to the concept of Euler graph. Here is a graph with 4 vertices and 7 edges. Let us know the definition of graph. A graph G consists of 2 sets V and E. V is a finite non-empty set of vertices. E is a set of pair of vertices called edges. The vertices of a graph G can be represented as V of G. Likewise, the edges of a graph G can be represented as E of G. There are 2 types of graphs, directed graph and undirected graph. For undirected graph, a pair of vertices u, v or v, u represent the same edge. A path. A path is a sequence of vertices and edges. A cycle is a path that begins and ends at the same vertex. Euler path is a path that traverses every edges in a graph with no repeats. Being a path, it does not have to return to the starting vertex. And Euler circuit. Euler circuit is a circuit that uses every edges in a graph with no repeats. Being a circuit, it must start and end at the same vertex. Euler graph. A graph that contains an Euler path with at most 2 vertices of odd degree. Euler circuit contains all the vertices of even degree. The number of edges incident on a vertex is called degree of vertex. Finally, a graph is traversable if all the vertices have even degree or exactly 2 vertices have odd degree. Let us go back and take a look at the degrees of the graph that represent the bridges of Königsberg. Here the degree of A is 3, the degree of B is 4, the degree of C is 3, and finally the degree of D is 3. That is, 3 vertices are odd degree vertices. Hence, it is not possible to traverse the bridge exactly once by starting and ending at the same vertex. There are several applications of graph theory. The practical approach of graph theory can be applied to solve traffic problems, as it is the combination of vertices and edges. Network subtraction method can also be applied to the traffic congestion problem in order to regulate huge traffic on the road. Graph theory provides a powerful framework for modeling, reasoning about, and devising algorithmic solutions to diverse problems arising in airline scheduling. Using graph theory networks applied for finding the optimal path in the network to reduce power losses. In global positioning system, the fundamental set of independent loops based on different spanning tree is used to detect cross errors in the observation without using adjustment computation. Graph-based representation of complex networks provides simpler views, and graph theoretical techniques provide simpler solutions for lot of issues inherent in networks. Graph theory methods are centrally important to understanding the architecture, development, and evolution of brain networks. Thank you. If you like this video, do not forget to hit the like button and comment, and never forget to subscribe the channel.